This is exponential growth. We're looking at exponential growth functions, maybe some decay functions. What we're going to look at here is the formula and maybe kind of look at the graph, and so that we know what the shape of them are. The exponential function with base A is denoted by this. So here we've got a function with base A, denoted by this expression right here. F of x equals a to the x, where a is greater than 0 and a cannot equal 1, and x is any real number. So there's just some guidelines as far as what your base can be and what your exponent can be. Let's look at when x is greater than 1. And excuse me, this should be when a is greater than 1 right here. When a is greater than 1. All right, what we're going to do is just look at what happens for the graph. First of all, we can do that by building a table of values to start off. What happens when x is 0? Well, what is a to the 0 power? A to the 0 power is always 1. So I know my graph is always going to cross here, the y-axis at 1. And then I can put in other values. So what happens when x is 1? So it would be a to the first power. Well, if a is greater than 1, and a to the first power would just be a. And then a to the second power would be a squared. And you can see here that it's slowly going to increase. So this exponential growth function looks like this. And we also know that the output would never be 0. So it's going to slowly approach the x-axis but never cross. So that'll be our asymptote. All right, this is our growth right here. This is what growth would look like. So these powers 1 and 2 get large. And if I pick negative values, let's say I pick -1, then if I evaluate that at -1, it would be a to the -1, which is 1 over a. So now we're talking about values getting smaller, which is why it goes towards the x-axis. All right, let's look for the function here when a is between 0 and 1. When a is between 0 and 1. Well, we already know what happens when it's at 1, y-intercept. But what happens if I substitute a number in such as power of 1? So if a is between 0 and 1, that means this is a fraction. We have some sort of fraction such as, 1 over x or something. We don't know what it is, but it's some sort of fraction between 0 and 1. If I raise it to a power of 1, this value is small. It's a small value. So as I raise this exponent even higher, like a power of 2, whatever this fraction is, it's getting smaller and smaller. So those values will become closer and closer to 0. And so you can see that this function goes this way. That's my exponential. This is a decay function. So as x increases, y gets smaller. All right, that's what the two graphs look like. Both of them have y equals 0 for our horizontal asymptotes. Y equals 0. Let's look at what we got going on here. The graphs of exponential functions. State the following facts about the graphs of exponential functions. These all come from considering the equation f of x equals a to the x. State any asymptotes. With this exponent, a of x, right here, no matter what we do, we'll never be able to get a 0 from it. So that would tell us that the function cannot equal 0, or y equals 0, because we're never going to be able to evaluate and get an output of 0. State any intercepts. Well, since y cannot equal 0, if that's an asymptote, then it's never going to cross the x-axis. So as far as the x-intercepts, there are none. And we already know that the y-intercept, as long as this is our formula here, or our function, the y-intercept will always be 0, 1. Of course, we can have some shifting of our graphs, left, right, up, or down, but this is for the generic case here. Y-intercept is always 0, 1. Determine if the function is increasing or decreasing. Well, increasing goes along with our growth function, and decreasing goes along with our decay. So it increases from negative infinity to positive infinity as long as a is greater than 1. And it goes, this is for decreasing now, decreases from negative infinity to positive infinity as a is between 1 and 0. Okay, so this is for increasing, and this is for decreasing. And what we can do is we can get all of this information from our graph. What's the behavior of the graph? All right, state the domain. So we know our domain for this is all reals, so negative infinity to positive infinity. And our range would be from 0, but not including 0, to infinity. And again, if you have to look at the graphs for that to see it, you can. All right, so that's the important information that we have. The next thing that we're going to do is we're going to practice graphing several of them. Here's our first one that we're going to graph. All right, we've got f of x equals 2 to the x. And here are the points that we are wanting to put in to our function. We want to put in -2, -1. We always want to put 0 in, although we know the output's 1. +1 and 2. All right, so let's go ahead and evaluate these. If I put -2 in, this would be 2 to the -2, which is equal to 1 over 2 squared, or 1/4. Remember your negative exponent rules. If I put 2 to the -1 in, that's 1/2 to the first, so 1/2. If I put 2 to the first is 2, 2 to the second is 4. So we're going to plot these points. We've got 0, 1. We've got -2, 1/4. -1/2. We've got 1, 2, and 2, 4. So something that you're going to have to do is you're going to have to be able to graph these functions by hand. One of the main things. Now, we also want to do other things here by noticing some of the asymptotes. You can definitely see that the y equals 0 is my horizontal asymptote. You can also see that the domain is from negative infinity to positive infinity. All right, let's go ahead and look at the next graph here. So I'm going to go ahead and build my table of values. Again, we went from -2 all the way to 2. I'm including 0 here in my table. I know you're missing that 0 in your set of ordered pairs, but we do want to know and plot that point. We know that it's 1 for the output. All right, let's put -2 in. So this would be 2 to the negative of -2. Well, that is just 2 to the second. So we know the result is 4. And we can kind of follow that same thing here. All right, so here's what we've got. Let's see, what were we putting in here? 2 to the negative of -1. So that's just 2 to the first, which is 2. If I put 1 in, I get 2 to the -1, which is 1/2. And if I put 2 in, it follows that same type of scenario, 2 to the -2, which is 1/4. Remember, negative exponents, you do the reciprocal and it changes to a positive. So let's go ahead and plot these points. I do know that I have a horizontal asymptote at y equals 0. So, if you want to place those asymptotes in there, that will help with the curve of your graph. And otherwise, you're just going to plot. So we can put in -2, 4, and -1, 2, 0, 1, 1/2, and 2 1/4, and it just will slowly approach the line y equals 0. And that's what this is going to be your exponential decay then. So we've got our point 0, 1 as being an intercept. We've got y equals 0 being an asymptote, and this is a decay function. These are some important parts to it. You can see as x goes to infinity here, then the graph is getting smaller and smaller, and that's a decay. All right, let's go ahead and take a look at these other examples. We got 4 left that we're going to continue with this video. It says graph the exponential function by hand, identify asymptotes, intercepts, and determine whether the graph of the function's increasing or decreasing. In other words, is it a growth or a decay? All right, so the first one we're going to do is f of x equals 3/2 to the x. And what we're going to do when we graph these is we're just going to go ahead and plot a few points. And we already know a general idea of what it's going to look like. Since this 3/2 here, it's bigger than 1, this is a growth. We also know this general form, y equals 0 is an asymptote, and 0, 1 is an intercept. Let's go ahead and put this information in. All right, I'm going to go ahead and there's my asymptote. I've got a point at 0, 1, so let's put some points in. If I put in an ordered pair, if I try putting 1 in, then I know that the result is 1.5. If I put 2 in, I get 9/4, which is 2 1/4. If I put -1 in, I'm going to have to do 3/2 to the -1, which is actually 2/3. And we already know what happens to this graph. It's going to come from positive infinity and go towards that asymptote. So there we go. That's the graph of f of x equals 3/2 to the x. Let's try the next one, which is f of x equals 3/2 to the -x. All right, we've got, again, similar situations here. We've got our horizontal asymptote, y equals 0. Since this function is the same as doing 2/3 to the positive x, then I know that it's decay because 2/3 is smaller than 1, and the intercept would be 0, 1. So plot that point. If I put 1 in, I get 2/3. If I put 2 in, I get 4/9. If I put -1 in, this would be 2/3 to the -1, which is actually 3/2, so up 1.5. And if I put -2 in, it'd be 2/3 to the -2, which is, again, you flip it, 9/4, so up to 2 1/4. So here's my decay. We know what decay is going to look like. There we go. That's how you graph these functions. You just plot points, at least graphing them by hand. All right, now let's look at letter C, which is g of x equals 3/2 raised to the x plus 2. That x and the plus 2 is all up here in the exponent. Let's just see what that plus 2 is going to give us, what kind of relationship. All right, let's do that by plotting some points. So let's put -2 in. -2, if I substitute that in, I get 3/2 to the 0, which is 1. Let's put -1 in. 3/2 to the first power here, if I put -1 in, so that's 3/2. Let's put 0 in. 3/2 to the second, which would be 9/4. It looks like I'm starting to get larger in this direction. Let's see what happens when I go to -3. 3/2 to the -3 plus 2, which would be 3/2 to the -1st, which would equal 2/3. Now it's starting to get smaller, 2/3. This will give us enough points here that we can graph and kind of see what's going to happen. All right, so we've got -2, 1, -1, 3/2, 0, 9/4, -3, 2/3. It looks like my graph is going to cut through here, slowly increase, and slowly approach. Now I want to just show you the point that what that +2 is doing with my graph. That +2 here, this point has been shifted from the original y-intercept. It's been shifted left 2. So this is still a growth. This +2 here shift my graph left 2. Y equals 0 is the asymptote, and my order, or my intercept, is actually 0, and it was up 9/4. So those are some important parts to this one. Now what we do is we have one graph left, one more graph, and the function is f of x equals 3/2 to the x, which is negative, and then you have this +2 on the outside. Well, we know what the +2 is going to do. The +2 shifts our graph up 2 units. It's no different than our polynomials and our quadratics. But we can build a table of values. Try to plot a few points. All right, let's go with, let's go ahead and put in 0. What happens when I put 0 in? I get 3/2 to the 0, so 1 plus 2 is 3, so I'm up 0, 3. So I know my y-intercept is 0, 3. Let's go ahead and put in 1. 3/2 to the -1st, that's 2/3. 2/3 plus 2 is 2 2/3. With those negative exponents, you're going to want to make sure that you flip your fraction. Over 1, up 2 2/3. Let's do one more. Let's put 2 in there. So that's 3/2 to the -2, which is really 2/3 to the second. And then plus 2, that's 4/9 plus 2 is 2 4/9. You can see here that it's getting smaller and smaller, which is indicating that I've got a horizontal asymptote at 2. And if my graph truly is being shifted up 2 because of the +2, then y equals 2 is my horizontal asymptote. I've got, this is a decay function, and I'm just going to go ahead and put one more point in. What happens when I put -1 in? Well, -1 here would give me 3/2. 3/2 plus 2, or 1.5 plus 2 is 3.5. So you just evaluate. You guys can evaluate. Here's my graph. It's coming from rising and then slowly lowering towards the asymptote. So we can see this +2 here. What that does is it shifts your graph up 2 units. All right, that is it for this first video with growth and decay models, and then doing some sketching by hand.